The fundamental passive linear circuit elements are the resistor R, capacitor C, and inductor L. These circuit elements can be combined to form an electrical circuit in two distinct ways: the RC circuit and the RL circuit.
An RL circuit, sometimes called an RL filter or RL network, is an electrical circuit made up of passive circuit elements of a resistor R and an inductor L linked together and driven by a voltage or current source. An RL circuit, like an RC or RL circuit, will consume energy due to the inclusion of a resistor in the ideal version of the circuit.
An RC circuit is an electrical circuit consisting of passive components like resistor and capacitors, driven by the current source or the voltage source. RC circuits are common in everyday life. They are used to control the speed of cars, windshield wipers, and the timing of traffic lights. They are used in camera flashes, in heart pacemakers, and many other electronic devices.
These circuits will be explored in this experiment using the multisim software. Materials are 100 watts lamp, 1.389 Henry inductor, 5 microfarad capacitor, AC supply, ammeter, and voltmeter. The first part of the experiment is the RC circuit. To start, connect the circuit shown in Figure 1.
Measure the total current and the current across the lamp and across the 5 microfarad capacitor. Turn on the run button to simulate the circuit.
Measure the voltage of the source, lamp, and the capacitor. Turn on the simulation.
Using Ohm's law, compute the voltage and current for each component. Record it at Table 1 and 2.
Compute the magnitude and phase angle of the impedance using the equation impedance C is equal to resistance R minus J times the capacitive reactance XC, where XC is equal to 1 over 2 pi times frequency times the capacitance.
Compute the percent difference between the measure and the computed value of the impedance.
Moving on the second part of the experiment, the RL circuit. Connect the circuit shown in Figure 4.
Measure the total current and the current across the lamp and across the 1.389 Henry inductor. Turn on the run button to simulate.
Measure the voltage of the source, lamp, and the inductor. Turn on the simulation.
for series RL circuit. Using Ohm's law, compute the voltage and current for each component. Record it at Table 1 and 2.
Compute the magnitude and phase angle of the impedance using the equation impedance C is equal to resistance R plus J times inductive reactance XL, where XL is equal to 2 pi times frequency times the inductance.
Compute the percent difference between the measure and the computed value of the impedance. For our takeaways, by this experiment, we can identify the impedance of a series RC and RL circuit.
We are also able to explore the relationship of current and voltage, where the current lags in a series RL circuit and leads in a series RC circuit.
We learned that the reason behind the discrepancies is the fact that the multisim simulation has a limit of decimal places it can show in the ammeters and voltmeters, which means that the values of the software provided were already rounded off, while the values we acquired from manual computations have a longer limit than that of the multisim.
Also, proper placement of the measuring devices is also needed to ensure the correctness of the values being obtained, where the ammeter must be in series to measure the current while the voltmeter must be in parallel to measure the voltage.
We observed that just like in a DC circuit, the currents in an AC circuit, like the series RC and RL circuits, are constant, or the same throughout the circuit.
On the other hand, the voltages across a series RC and RL circuit are additive, just like in a normal DC circuit. And this ends our presentation. Thank you for listening.